For our polygenic inheritance lab today, you are going to be making a fingerprint impression, and you are going to be counting the loops and whorls and arches on your fingerprint. So this is a fun lab. It's an easy lab to do. The data analysis is relatively straightforward. So the data collection basically consists of you lifting your fingerprints for all 10 of your fingers, and then counting up, totaling the variation you see in your fingerprints. So to do this, you are going to take a number 2 pencil. If you have one that you know is number 2, it's going to work better. And on a piece of scratch paper, you're going to make a really, really dark, thick smear of that of that pencil lead. And you may have to refresh this a few times. You may have to make a new smear of pencil lead as you're going through this. Then you are going to basically smudge your finger in that graphite. Basically in a circular motion, you want to get it all over the whole tip of your fingerprint, focusing mostly on the pad of your fingerprint. So if this is a very terrible image of your hand, you're going to have your fingerprint tips, and you want to get that graphite all the way as far as you can on the flattest edge of your finger. So if you push real hard and you get a wide, flat fingerprint, that's what you're looking for. Go ahead and rub out on the edges as well. And then you are going to take a piece of Scotch tape, lay it across your fingerprint, kind of rub it on your finger sideways and vertically to get as much of that fingerprint as you can. And then you're going to very carefully peel it off of your finger and then tape it down into your lab manual or onto a piece of paper. You'll notice that in your lab manual, there's a space for all of your fingers so you can keep track of them. So you want to try really hard to collect the center of your fingerprint, which is actually a little farther down than you might think it is. If you look real closely at your fingerprint, you should see these whorls and loops in the center. That's really what you're trying to get. And you actually need to usually get out into this region over here, because that's where, or even on this side, because that's where you're going to see the tri-arches if you have them. And that's what you need to be able to determine the fingerprint pattern. So I'm sorry, I said tri-arches, I meant tri-radius. This is if you look at your fingerprint, you've got these loops and whorls. The tri-radius is a point where those loops and whorls come together. So you're kind of trying to make sure that you get that tri-radius off to the side of your central fingerprint if you have one. So here's an example of the different shapes you're going to be looking for. I'm going to start with the loop in the middle. So over here is your tri-radius. So you'll see this is sort of a 3-point curve here. And you need to identify in your fingerprint the tri-radius and then whether or not you have arches, loops, or whorls. So here we have one tri-radius, and this is going to form a loop in your fingerprint. So we've got all these loops that come up around that central loop. Now you are going to be counting up the arches, loops, and whorls. I'm sorry. You're going to be counting up your loops and whorls. You're going to be looking for your arches. Your arch is defined by having no tri-radius. So you'll notice here we don't make any central loops. We don't have one of these tri-radii here in the center. So this is going to be an arch. You would just label this finger as an arch, and you would say that it has 0 loops or whorls in it. If you have a whorl, this is because you have 2 tri-radius points. So you'll notice that all these loops and whorls come together at these 2 different points. You are looking for 2 tri-radii to identify a whorl. So if you identify a loop or a whorl, you're going to label that fingerprint as a loop or a whorl. The next thing that you're going to do is count the number of ridges. So the number of ridges depends on the tri-radius. Now remember, if you have 1 tri-radius, you have loops And if you have 2 triradii, you have whorls. So once you identify arches, loops, or whorls, you're going to need to count the number. So if you have arches on your finger, no triradii, then you have 0 ridges. I realize that there are structures there, but this is how we count them. So you have 0 ridges. So on your data sheet under number of number of fingers that has arches, you'll make a tally mark for an arch, and you will have 0 to add towards your total ridge count. If you have loops or whorls, you're going to start from one of your triradii. And if you have whorls, you're going to look for the second one. And you're going to count both from the corner of the triradii to the center. So this one has 1, 2, 3, 4, 5, 6, 7, 8 ridges. So this one is a loop because it doesn't have a second triradii. If you have a second triradii, like let's say we have one down here, actually it'd be more off to the side, sorry. You're going to count the number for both of them and use your total ridge count that's higher. So if we have a whorl pattern, you're going to count the larger of the 2 counts. So 3 things you're doing here. You're identifying if you have a triradius, if not, you have arches. Then you are then you're determining if you have a loop or a whorl based on the presence of a second triradii, and then you're counting your total number of ridges. Again, if you have a whorl, you just count the larger of your ridge counts. So then you're going to record this into your data chart, your number of fingers with arches, loops, or whorls, and your total ridge count from each of your fingers. And then we are going to collect class data. Now, if we're doing this in class, I would post this. We would collect our class data, and I would add in other student data from previous semesters because we have a very small class. Since we're doing this online today, I have posted the total ridge counts and arches, loops, and whorls table in the Brightspace lab module for polygenic inheritance. So you can go in there, collect the other student data that you need, add that into your chart, and then you are going to make a graph very similar to this one. This one is found in your lab manual, and then answer the questions that are related to the lab. So to make your graph, you are going to total up the number of individuals with each of these ranges of ridge counts. So for example, we have 3 individuals that had a total ridge count of between 40 and 60, 4 that have a ridge count between 60 and 80, and so on. This is a published study, so this is not my class data, but you are going to make a chart based on this semester and previous semesters' historical data for the fingerprint ridge analysis. And then you are going to look to see whether or not your class data follows a normal distribution.